Thank you very much. So good morning, afternoon, and evening to everyone, depending on what time zones you're in. Today I'm calling in from the East Coast of Canada in our headquarters here in Halifax. My name is George Palikaras. I'm the founding CEO and president of Meta Materials Inc., Meta for short. We are a NASDAQ listed company under the symbol MMAT. And today I'm going to go through some of the latest updates on our company, a little bit about what we do, who we are, and some exciting progress that we've made. As it's customary, there's some forward-looking statements. I'm not going to go through all of it. I'm sure many of you understand, just showing this slide. It's regarding forward-looking statements that will be made in this presentation. Okay. So as people know that, in every age that has gone by, whether it's the Bronze Age, the Iron, Stone Age, etc., there have been many breakthroughs that have been a result of material science advancements. In the last 60 years, for example, we have experienced an incredible a breakthrough in material science in the semiconductor industry. And that happened with the invention of the transistor, which then led to creating microchips. And as we know all, the famous Moore's law, basically compacting as many of those transistors on a wafer, on a silicon wafer, has been the incredible benefit and leapfrogging for technology, for innovations in telecommunications. This is what is driving today the smartphones, the smart cars, and everything else that comes in the adjacent markets. At Meta, we deliver breakthrough performance across a number of applications and industries. And we do that by designing, developing, and manufacturing sustainable, highly functional materials. We do so by nano-patterning them. So the mission of our company is to democratize nanotechnology, and by doing so without harming our world. This is just a quick image of what I was just explaining. What you see on the top is a computer, basically something that took over hundreds of square feet is now scaled down to basically a few inches across your table and millimeter thicknesses. And this is all done not only by the incredible engineering of companies like Intel, etc., but really the advancements in material science and how to manipulate the properties of matter at the small scale. Today, we are experiencing a new age, an age of invisible materials. As you can see here in the gray images, these are zoomed in electron microscope images. So you take basically a very powerful microscope to zoom in to nanometer scale, and you can see different shapes and patterns. Now, some people may not have come across metamaterials. What are metamaterials? Metamaterials are very different because they control on demand the functional properties of matter so that you can engineer properties. So imagine that you would like to absorb, emit, sense, transmit, and guide light and other forms of energy, whether it's sound, electromagnetics, electricity, etc., on demand, at low cost, and at large scale. Now, this industry has spun out of the semiconductor industry. So metamaterials had a problem. Up until about 10 years ago, when it was about the time that we started, Meta believed that we would be able to go to the semiconductor industry with our beautiful designs, similar to the ones you see here, and print them at scale. Unfortunately, 5 years into the life of the company, we realized that the semiconductor industry was using old techniques that were perfect for a wafer business model. So anything on a wafer has a certain price point. It's a step and repeat process, and roughly costs between $15,000 to $30,000 per wafer, depending on what you're making. Now, the product on a wafer is a chip. It's like a sub 1 millimeter square die. The products that we started making were windows of aircraft, windows of automotive electric vehicles, and that required a massive drop in price, which did not exist. So while we were working with the semiconductor industry, we realized this would be a major roadblock. So we turned our attention to the chemical industry, the specialty chemicals companies that today are our partners. They had technologies that could scale in bulk. However, the precision was not there. The control at the semiconductor level was not there. So at that moment, 5 years into our work, we invented our own manufacturing tools and then acquired a few other tools that helped us take the film that you see here on a wafer scale to meter square and now roll to roll kilometers length. So the three advantages that we bring to the table are: number one, speed, not only to manufacture these materials, but to design them. Speed for us means how do you execute on a new design, a new inquiry from a customer. What chemical industry and semiconductor industry takes sometimes months and years to do, we can do it in typically hours and weeks. What previously the scale, which is the second advantage, took the semiconductor industry tens of millions to scale, we can now do at high volumes in large areas. And what previously took roughly between $50,000 to $100,000 a square meter for the semiconductor industry to achieve, we can now do it at a fraction of the cost, down to a few dollars per square meter. Now, what about the market? So there is a massive market opportunity that's driven by several megatrends. The metamaterial segment of that market is enabling communications, sensing, and other types of applications, including electric vehicles and 5G in particular. Now, I mentioned megatrends. You can see here on the left a few interesting things that are happening. The first one is the 5G infrastructure. Right now, there is more than a $1 trillion rollout in 5G infrastructure happening just in the Western side, Europe and the US, with an additional $1 trillion happening in the Asian side. I will talk a little bit more in detail on the 5G application as we go forward, but this is a major opportunity for us, and the need there is to have new materials that are transparent, that can blend in the background without any issues. The second megatrend is vehicle electrification. There is a massive shift towards electric vehicles, as everybody knows, and with it comes addition of new sensor systems. Vehicles are becoming much more complex. Electronics, LiDAR, sensors that sense the surrounding, autonomous vehicles and driving, all geared to become basically to help drive forward safety and enhance passenger experience. So combined with the other verticals, we see major advances in medical, energy, aerospace, and automotive markets. All of these markets have one thing in common. There is a challenge. They depend on scarce, rare earth materials that are basically not abundant around the world. So one of the biggest opportunities for metamaterials is, and this is the promise, is to replace rare and scarce materials, such as indium, with something that's commoditized, such as copper and aluminum. So if you can take those commodity materials and outperform the thing that they're replacing, which is a scarce material or a rare earth, and you can do that without losing performance. That is the promise that we are offering today, and that makes a product that's not only more sustainable, but really a breakthrough in terms of performance. Let me show you some examples. Before I do, I just wanted to say that we focus today on 3 pillars. The first one is protect, the second one is connect, the third one is detect. And we have built a platform technology that is capable in holography to nanostructure, nanopattern polymers. We have a major partnership with Covestro in Germany. In lithography, where we nanopattern metals, we have a major partnership with chemical company Sekisui in Japan. And in wireless sensing, which is commonly available across the field, lots of supply chain partners, which we cannot talk about today. So some applications that will help you understand how we use these new materials. The first one is in LiDAR. In automotive, LiDAR has existed, since the time in aerospace and the military. It's coming to automotive now. LiDAR helps protect and basically enhance ADAS and the safety systems. However, as you may have seen recently in the news, there are certain EV companies that have had challenges with icing and fogging up, but also EMI shielding has come up as an issue. So sensors start to interact destructively with each other. So imagine you have one system on board and it affects another system on board. So how do you help create basically efficiency across the systems? And also, how do you protect your sensors against the weather elements? We have made a film that gets applied. It's called NanoWeb. It's a transparent metal mesh. It has the world's highest transparency and highest conductivity combined. It is capable to allow the systems to see through that film without adverse effects. Now, the same technology can be shaped. By shaping a piece of metal, as you may know, you can create antennas. Imagine they were transparent. You can see here in the gray image in the background, the scale of our nanomaterials. This is a 200 micron scale. Our lines are typically in the range of 400 to 600 nanometers. And 1 nanometer is a billionth of a meter. So you can imagine that we are very, very transparent. In fact, we are invisible. So our lines here, as you can see on the photo, you can not see them with a bare eye. This makes this technology particularly interesting in electric vehicles and normal ICE vehicles, combustion engine vehicles, because you can put it directly on headlights, directly on windshields, front, back, top, side, and bottom, basically anything that has a transparency. And that allows us to bypass certain regulations that exist in automotive. But there's more. These films can be also embedded in smart eyewear. This is a $1.5 billion augmented reality market that is growing very fast. One of our partners, as I mentioned, is with Covestro, who are providing us specialty photopolymer chemistry, which we then convert into beautiful display films that can seamlessly blend within the smart lens. Now, this technology can be also applied on windows, not only on smart eyewear, car windshields, etc. And we have the technology not only to make the nano pattern film, but also to integrate it inside a lens with UV curable materials. We have acquired a lot of this technology throughout the time from a Swiss company called Interglass Technology. And since we acquired them, there's been incredible traction with some of the Fortune 500 companies, which today I cannot talk about. We have a program running, which we are in the second year. We expect from a supply chain perspective, some major improvements and launches. At the June time, we will be presenting some of our results at AWE in Santa Clara, which is the Augmented Reality World Conference. In the mid to long term, we have some incredible opportunities in image enhancement and sensor enhancement. These, again, are metamaterial devices that are focused on medical applications. As you can see from left to right, there are different types of devices, but they all have one thing in common. They use metamaterials to enhance their performance. On the far left, you see an MRI device. This currently holds the record for our company, a 40x improvement in signal-to-noise ratio enhancement with a $2 billion market potential. MammoWise, which is an early-stage breast cancer screening, again, enhancing through the skin and enhancing the imaging, detecting earlier stage tumors that you could basically do without compression, so without the pain, and doing so with a metamaterial film gives you higher quality results. And on the right side, you have two sensor arrangements here. The first one is a non-invasive glucometer, which is the holy grail for medical diagnostics. You can see the market potential is enormous. And finally, a molecular biosensor. Now, these are all in different phases of development. However, we have had success in animal and human trials for most of them, and we are fast approaching milestones and key dates that we will be able to announce results. So a little bit of focus, I mentioned at the beginning of the presentation, on 5G. 5G is a big, important sector for us right now. I mentioned that we have a partnership with Sekisui Chemical, who are helping us innovate in this space and are sharing the risk with us in terms of investment. As you can see here, there's a film that is applied on the windows of these buildings. It is intending to do one thing, to enhance coverage, especially in black spot areas. Some of you may know that the 5G has two bands. The mid band, which is a sub 6 gigahertz, and the high band, which is about 27.5 gigahertz. At the high band, you do not get anymore this bouncing effect that you get at LTE or 3G, lower 4G type applications. What happens at the high band is that the buildings, the trees, the people, they absorb that energy very efficiently. So that creates a lot of black spots, basically areas that are not covered. The same thing is not only outside, but also inside. So the signal never reaches inside. And you'll notice that if you have a 5G enabled phone, once you go inside, you may lose 1 or 2 bars in your phone. That single 1 bar loss is 1 order of magnitude loss. 2 bars, 2 orders of magnitude. And then basically your phone will switch back to the previous speed, which would be 4G or 3G. Now we make a film that allows the signal to penetrate through the glass, reflect inside, and basically enhance the penetration throughout the building, but also reflect the signal and create hotspots outside of the building. So let's see how it works. It can create, as we said, a very transparent film. Just to give you an idea, here on the right, you can see micron lines versus our nanoweb. This is a competitor product. You can see how it looks. They call that transparent. It's not. But you know, anything, I guess, that you can see through is transparent. We are offering a solution that is totally invisible to the human eye. And you can see in the top right here, the film has special patterns that are proprietary to us that control the beam in direction and in strength. This is a little video here that shows the effect. So as you can see, the film is visually clear. When you zoom in, you can see there is a special pattern with nanoweb, and you can create many reflection modes by controlling the mode of reflection. It means that you can now build and infrastructure with less base stations. The biggest benefit here is that if you're rolling out, for example, in a hospital or a big building, your infrastructure cost can be significantly high, especially in the high band 5G, where the electronics and the hardware are expensive. What you see here is the actual demonstration of our product. This is a piece of metal, it's aluminum, and you can see the beam gets perfectly reflected to the receiver. The receiver receives about 98% signal. All fine by now. Now, if you take that film or piece of metal out, which is our reference, and now you replace it with our nanoweb, which is totally transparent, as you can see, you get the same bounce. And now from a totally transparent surface, you get 98% signal. But there's more. What if the film was bent and you now need to control the beam and steer it to a different angle other than normal? A piece of metal, just like the previous reference, would never be able to bend that backwards to the receptor. You get almost nothing. So by replacing our nanoweb with the right type of nanoweb, you can now steer the beam, and steering the beam to where you want it most. And we control that angle very accurately. You now have an offset reflector, which now gives you back your signal, and you can still see now your 90 plus 98, just like before. Isn't that amazing? So what we see here is basically the ability with a software-driven approach to enable various modes of reflection and be able to cover a wide range of applications within buildings and outside. This is an example here on the right where you can see simulated environments. They have 10 rooms, hallways, etc. This is the high band, as I mentioned, 28 gigahertz. And on the right is with our film, on the left is without. And you can see there's a lot less blue areas on the right, more blue areas on the left, which means that there's more signal with just a single application of our nanoweb film. We are showcasing this technology constantly. We're rolling it out, scaling the technology. There's a lot of work to be done here, but this is just an example of one single application as I deep dive, and there's more to follow. Just to go through, some of these are selected, targeted co-development partners and customers in different market segments. We started in aerospace. We are now moving into other markets, and we're very proud for what we have achieved. From a competitive perspective, there are a few metamaterial companies, but they're only singularly focused. They're not platform companies. They're only doing one product. And then the semiconductor and chemical specialty materials companies, you can see some dotted boxes around a couple of them. Those who were our suppliers, who then became our potential competitors, are now becoming our partners. And really the message here is that we are really shifting the performance and cost curve in this material space. So we are very excited that, you know, some of the top Fortune 500 and Fortune even 10 companies are reaching out to us now. Our IP portfolio is very deep and more than 250 patents in not only devices, but the manufacturing techniques. And we have added a new segment, which is authentication, which I'll talk very briefly about. Our team is growing. We have some incredible depth in our bench. Recently, Brian Donnelly joined us as EVP for sales. From a roadmap perspective, we are scaling. Right now, we're in the final phases of our new headquarter facility, which has 12 clean rooms, 68,000 square feet, center of excellence. It's underway. And we have recently launched our pilot scale production in Pleasanton, California, and Silicon Valley with a commissioned roll-to-roll pilot line. About 6 months ago, we executed an acquisition which added tremendous amounts of new capabilities and equipment. A company called Nanotech Security Corporation, which produces nanostructured security holograms for banknotes. What's interesting about this is that the design, the origination, even the production tools are very common in both of our businesses. So it made a lot of strategic sense for us to join forces. And we were able to basically put together an incredible workforce, which is in addition to a 105,000 square foot manufacturing plant in Thurso, Quebec. We have about 130 people right now in the team across the board, and some very, very special manufacturing equipment. This is our last quarter's Q3 financial statements. As you can see, we have very modest revenues. We are working very hard with the team to bring in very high value business. And the type of value business, you know, for every dollar typically that our customers spend, there's about $10 of revenue in the future. And we are very selective of who we work with. We have a model which is to deliver more than 50% gross margins on average. Typically, we have products that go up to 90 plus. And choosing the right partners, the right companies allows us to basically build a very successful team in the future. Our revenue target is $600 million in 2026. So to summarize, we have built a multifunctional expertise in the team, starting with design and moving on to manufacturing and scaling up, using proprietary production tools, producing scalable and sustainable products that have been winning awards from the industries that we're in. Our latest award was from Lux Research for our 5G innovation. We have a software approach which gives us an edge over our competition, which takes sometimes years to develop solutions. It takes us days and weeks. We have a very sound IP estate, more than 250 patents. We have established partnerships with Fortune 500 companies, growing our business in partnership with some of the top chemical companies and material companies. And we have become the first metamaterials company on NASDAQ, which has allowed us to leverage not only our innovation platform, but recruit some of the top engineers and talent in the world. Thank you very much.
Thank you for the great presentation. I think we still have about 15 minutes left for questions. So for the audience, you can post questions in the chat or the Q&A function. So the first question is regarding the dividends. Are there updates? But I think currently this is not a goal.
Sorry, can you repeat the question?
The first question was about dividends. What's probably the long-term play?
All right, the long-term play on dividends as a whole, obviously we are at the growth stage of the company, and we intend to, obviously announce any dividends in the future once we reach profitability, just like any other company. When it comes to the special dividend or the preferred day shareholders, there's from Torchlight, I guess, is kind of maybe the question. There is updates that we have shared in the last few weeks. We are working very hard to spin off the assets, and basically with that process there will be additional press releases. You can reach out to our team, Marko Winowski, and basically he can give you updates. But in the meantime, any updates will come through our official press release process.
Mm-hmm. The next question is there even any direct competition, or are they just miles away or in different sectors?
So that's a great question. When it comes to direct competition, I mentioned I had this slide earlier, which talked about the landscape, in the competitive landscape. Metamaterials are a new scientific field. So it's been in science, in the laboratory for the last almost 20 years, being incubated. The major application started in aerospace and defense. As you can imagine, companies would not patent what they produce under strict confidentiality and restrictions from the government. One of the things that we learned very quickly was that there were a vast number of applications that in the non-aerospace and defense space that needed attention. Mm-hmm. But finding the right volume applications, etc., became part of the first challenge. The second challenge was, could you scale it? In hardware, the question is, can you make it? Then it's, can you scale it? So to date, we are the first metamaterials company to reach this kind of scale, where we have about 7.5 million meters square of production for our nanostructured films in Thurso, Quebec. This is based on our nano imprint lithography tools. As I mentioned, there is a contract with Nanotech Security. This relates to the banknote industry, where there is a more than $50 million framework agreement. We believe that we have the best technology, scale, and team available to deliver on this type of metamaterials. When it comes to competitiveness, everybody wants to stay ahead of the curve, and we continuously invest in our capabilities and scale, and that's why we are attracting Fortune 500 companies, and that's why we have intentionally built a very powerful IP portfolio to create freedom to operate for us and a higher level of, let's say, a bigger wall for the competition to, to protect our interests.
And regarding those windows, does the nano web need to be built into the windows, or can it be just glued on existing windows?
So you can actually print NanoWeb directly on glass if that was your desire. We typically find that it's much cheaper to build it into the interlayer. So if you think about any glass structure, especially safety glass, where you have typically double glazing or triple glazing, between the two glasses, there is an interlayer. And the best way to approach this is to put our film in that interlayer, in the glue that then puts the glasses together, and you have your product in between the two glasses. That is the cheapest way, and that's a way to scale it, roll to roll. Otherwise, you'd have to go to roll glass, which is an area that we are exploring with thin, ultra-thin glass, such as the Willow glass from Corning and other types. We have successfully printed on those very thin glasses. But right now, the approach is that you can do either, depends on the application.
And then there is someone from the audience saying that there was an article about Samsung phones having metamaterials for under-screen fingerprint sensors, and if you can confirm this.
So what I can say is that we have a joint publication with Samsung that is directly linked to the below the display fingerprint sensor technology. This is public information, but I cannot comment further than that.
Okay. And then there is another technology question. Could NanoWeb utilize the energy around us, for example, solar or UV or human electric current to help charge or sustain cell phones or AR or VR prescription eyewear, and could Meter potentially create adaptable prescription lenses?
These are all great applications. We have some levels of R&D and effort in technology with customers. So it's very difficult for me to pick out specifics out of that question. The gentleman or lady that's asking the question seems knowledgeable and creative enough, but I can tell you that our metamaterials can help with all of these applications. And the question is, how do we roll out our strategy? We have some very high valued customers that we're building up our relationships and products with them. And in the coming weeks and months, I think we will be able in a better position to showcase some of these applications.
And then there is a question regarding cars. Could it replace the electric cables in cars, or can it transmit data?
Yeah, so metamaterial antennas, etc., can receive and transmit data. I would not go as far as replacing wires in cars, and there's safety as well concerns, weight concerns as well, but there's power concerns, etc. So I feel that this is something that really comes out of the system engineering, the design teams of the automakers who specify what the next generation of anything, what is the specification, and obviously the cost implication. So one of the big challenges is, you can come up with a solution, but maybe it's not at the right price. Cabling, for better or for worse, are cheap right now. Due to the cost of raw materials, they become more and more expensive. But at this stage, I do not know any effort to replace cables and wire and harnesses in vehicles.
Okay. I'm not sure if you can comment on this question. Is ConocoPhillips buying torchlight property from metamaterials?
I do not believe that is happening. No.
Okay. And what's the current status on GlucoWise?
So GlucoWise, in the last few months, completed. It was a 2.5-year project that was sponsored by the British government, Innovate UK. We have reported on that, I believe, in Q3 last year. Since then, there's been a new levels of effort, obviously, going into the next generation of the development. And we believe by the end of this year, we'll have more results to share with investors. As you know, this GlucoWise it's a multi-year effort. We try to keep a low profile because there's a lot of trial and errors throughout the years, lots of failures. So we tried not to overly promote the medical applications because we just need to follow the rigorous steps for certifications, trials, development, etc. And we will be reporting when we have more results to share.
Yeah. The next question is regarding reporting. Can you already tell us when you will report earnings and or estimated earnings?
So by default, it has to be done by next month. So this is kind of a a simple answer. We intend to release the date in a press release, so I'm not allowed to say the specific date, but what I can say, it will be early in March.
Okay. And I'm not sure if this is correct. Can you comment on the interactions with Elon Musk?
What comment would you like to know about?
I think it was on it's regarding Twitter. Yeah, are there several ones?
Okay, so as I have explained in the past, we do share an address in Canada. Tesla Canada has its offices in the same building as us. Beyond that, we have the ability to basically offer technology to any electric vehicle company, and Tesla is one of those companies who would benefit from our product offerings. But due to confidentiality agreements, I cannot validate whether we do have or not have any relationship with any car manufacturer at this stage.
Okay. Yeah, so far, these were all the questions. We have 2 minutes left. Oh, one person is writing one more question. Now we can wait for the last question. Now another one is coming in. Can you talk about solar panels and the application of meter materials?
Yeah, so the solar technology that we are proposing and developing is all about to do with light management. As you may know, solar panels and solar cells have an angular, basically effectiveness. The angular bandwidth of the solar panel is known, is typically about 30 degrees. And what happens is, if you have a solar farm, you track the sunlight to maximize the efficiency with solar trackers. But if you put them on basically on anything that's fixed, the car roof or your house, basically at a certain angle, you'll get a certain amount of efficiency when the sunlight is within that cone of the angular bandwidth. What we do is we put nano patterns that enhance that, basically increase that angular bandwidth to roughly 160 degrees, which makes solar tracking not only not necessary, but also when you place it on angles like of 30, 40 degrees on houses and the rooftops, you get a lot more output from the same solar panel. So that's what we do. And from a status perspective, the acquisition of Nanotech has allowed us to basically push forward the solar program, and we'll have more to share later in the year.
Yeah, and the last question for today, the time is up, but we can take one more question. Does meter materials have applications that can change colors electronically?
So we have a material that is transparent and conductive, and when combined with the right photochemistry, you can create switchable materials. We don't do the chemistry for the, let's say, the switch, but we do make the materials that allow the switch to happen at low power with more efficiency and speed. So it would be a combination of us plus somebody in the chemistry world to create such effects.
Okay. Yes, thank you very much for your presentation and answering all these questions.
Awesome. Thank you very much. Great afternoon or evening.